Hey up! Part 2 of the Damascus bushcraft knife. Got my steel here. Now I'm going to explain, for anyone who's interested or anyone who wants to expand the knowledge on forge welding, why I'm going to do what I'm going to do and the reasons I've done what I have done. Okay guys, I'm going to try and explain what I'm going to do here and my reasoning behind it, my thought process. I'm going to try and not stray too far down the rabbit hole, because there's a lot of things I'm about to say here which also affects what I'm going to do and what I'm going to say. So I've no doubt this will be heavily edited now as I just stray off in other directions, but I'll try and keep it focused on just what I'm doing with these two pieces of steel. My two pieces of steel here now, the San Mai piece and the Mosaic Damascus, which as I said I've forged down so they're approximately the same thickness. Both the same, so we can get a nice weld and weld them together. Now the reason I'm using that is, it may not look like it, but that piece of steel, I'd value it at about £100, because the original billet of Mosaic that I made up took around 4 days to make. That's approximately a third of that billet, and this is the reason I'm going to use it rather than just, you know, kind of scrap it or throw it away. It will make a beautiful addition to a knife. It will really enhance the look. I'm hoping the San Mai piece on the bottom will hopefully add to that. So my major problem now is the length of the blade and the length of the billet. And you can see it still needs pulling out a good 2 to 3 inches, and the width. Now as I come to forge this down to weld that together, it's going to reduce that width again, so we're possibly going to be a kind of a third less than that. So for that reason I am going to do this. I'm going to forge weld this together on the anvil. I'm going to use the hammer on the anvil, and I'll tell you my reasoning for that as well. If I put this under the press is quite aggressive and you can only have a certain amount of control on it, so it's just going to want to really squash that down, but in that process it will extend the billet in length. But then by pulling that out in width, I will then really distort the pattern in the mosaic layer. So it's far better for me to use the anvil, and I can get really precise blows on that steel in order to stick them two pieces together. The secret with forge welding steel is to get it hot, as probably all of you know. But having especially tool steel at too high a temperature for too long robs carbon from the steel. The carbon migrates to the surface, it burns in the oxygen and it forms this scale on the surface, which is fire scale burnt steel. Now the reason I used the nickel in the San Mai, the nickel is a barrier between the 1095 or the edge steel and the kind of sacrificial 15N20 on each side of it. That nickel will stop to a degree the carbon migration. So the only place that carbon can kind of leach out of this core steel now, which is after all the edge steel of this knife, is through that side. And when I forge this knife out, I'm going to leave at least 2 millimeters on that edge that I can grind back to get rid of any decarb in that edge, because although, you know, how a blade looks is really important to me, you know, how it performs as a blade is more important, I guess, really. So I don't want to rob that edge steel of carbon. The mosaic is kind of sacrificial in a way. It just goes to make up the blade. It's not a working edge. That will be the working edge, the center of that San Mai, that 1095 steel. So I'm going to have to get this little billet, because I'm not going to be putting all that 20 ton of force with the press. I'm going to have to be gentle with this so that I don't squash this billet. All I want to do is weld them two surfaces together, and it's about time and temperature. A lot of people just think that once you've stuck two pieces of steel together, forge welding, that's it. Well, it is, but it's not quite that, because you need the grains in the steel in each side of that boundary. The boundary will be the center where they're joined, and you need the grains to travel through that boundary to then fully become one homogeneous piece of steel. and it's time and temperature that does that. The grain's got to be allowed to move through that boundary. If you don't do that, you will have two pieces of steel stuck together, but they truly will not be one, and they can break apart. So what I'm going to do with this, I'm going to tack the ends up here. I'm going to get this in the forge. Now I'm probably going to use borax on this. The good thing that borax does is it stops that carbon that migrates to the surface getting in contact with the oxygen and burning and producing even more scale and shale and fire scale. So it will present that to a degree, and that is the only reason I'm using it. I don't need it to do that forge weld. As you've seen, I can quite happily do that. But all the time that this billet is in that high temperature in order for me to do that forge weld with a hammer, I'm losing scale. So I'm going to put borax on to mitigate that to quite a degree, I would have thought. It's going to make a mess. It's par for the course, but that's what I'm going to do now. I'm going to weld them two pieces together and hopefully pull out in enough length, hopefully pull out enough width. But even now, you know, this, we may fail in some way, and this may not end up being this knife. It may end up being a smaller knife, a thinner knife. Well, you know, I've done everything I can to try and get around that, but let's see what kind of cake comes out of the oven when we've done. Before we start forging that, this is the big stack I forged out yesterday. You can see that the pattern's building up nicely. This is again, of course, a mosaic pattern, so this will be tiled. That will be the pattern you will see on the blade. I think I've not quite got enough layers in that. So once again, I'm going to restack this billet, cut it, restack it, and perform exactly the same process again, which will give me the layers I need. Okay, let's get this little piece of sanmai forged out. Forge is hot. It's the billets welded together. Let's get them in. Right, I'm going to gently start tapping these two faces together now. This is where it's important that sanmai, which is the part I'm hitting now, be properly forge welded and homogeneous piece of steel, because as you drive down on the end of them welds, if they are slightly off, they will just open up as you hit them on the end, and that will be the main part of the billet that I'm working on, forcing them together. I'm just going to clean that borax off now. Just have a look at that little joint, just see how close those two pieces of steel are. They should be really touching now. I'll put a bit more borax on just to keep the steel clean and prevent any more scale loss. You'd noticed before that I didn't clean the forge scale off the sides of the billet, and that was just simply to, you know, to prevent more steel turning to fire scale. So I left that fire scale on. This is the second attempt now at this, still not really hitting it hard, again on the sanmai side, just making sure that they're definitely stuck together, bonded together. And now I will reflux this. I'll clean it off, I will reflux it, have a look at it, and then I'll put it into the forge now for about 5 minutes and let that grain in the steel move through that boundary, and we can start getting a lovely piece of forge welded steel here. Right, this is the third heat, and now I'm just reinforcing that weld. On this side I'm hitting the mosaic now, I'm just hitting it from the opposite side really. Just strengthening that weld joint, stretching the steel out a little bit in the process. I still need quite a bit more steel here, but have not reduced the width of the billet because that width needs to be pulled out quite dramatically. Let's clean that borax off. I'm going to start hitting these faces now. I'm going to test this weld. I'm going to hit the face right on that weld and let's see if it opens up. It shouldn't do, it should be beautifully forge welded that on one piece of steel now. So I'm going to hit it on that joint from both sides and just see if it opens up anywhere. I'm pretty confident that it won't, and actually it doesn't do. So that shows me that that is a beautiful forge weld, and now I can start working on the tip. So I'm going to forge on the Sanmai side of the tip. So the Sanmai is where I want to bring the sweep or the edge of the knife up to the spine. I'm going to hammer that down, bring that up. I want the mosaic to be pretty straight along the top, but I also want it tapering down slightly at the tip, so I will work on the mosaic side slightly whilst I'm working on the tip. I'll just have to keep correcting the two so we don't get a big upturn in the blade. The blade actually drops down ever so slightly towards the tip, and I want to try and maintain that. You can see I'm checking the length there on the anvil because I've drawn the pattern of the knife on the anvil in Sharpie. So I'm going to keep going against that and checking. If you saw there, you'll see it's still about 1.5 inches, not long enough this. But working this tip in will give us a little bit more steel. It'll probably give us another 1/2 inch by just forging in this tip. Again, really aggressively hammering on that Sanmai at the front of the knife. You know, it just shows that that steel is beautifully welded and is not going to come apart. Just a little bit more correcting there. Keep it straight. Keep the spine straight. The spine will add a slight curve in it, which I will have to put in a bit later on. Check the length again, still not there. Okay, I've been at high heat for quite a while now, so to speed this up, I've put a spacer in my press and I'm putting it through the drawing out dies. So I'm lengthening the blade. What I did here, I lengthened out the handle, just the handle alone, and then just the blade section, the front end of the blade section alive. I left a fat piece in the centre, which I'm then going to fuller out sideways to make it wider. I'm really close to tolerances now on everything. I'm short on length. I haven't got enough width. Now at this stage, I've not missed many steps out on the forging of this, but what I did do, I put it back into the into the press with the fullering dies on, and I pulled that steel out sideways, so towards the back end of the blade I've widened it out by fullering the steel across, and now it's left it a bit notchy. So what I'm going to do is just kind of clean that up, straighten it up, push it back down, which again will increase the length slightly, and I think I'm not far off length now. As you can see, I'm almost there on length. The length will be right to the end of the anvil. Now my problem is that the back end of the knife isn't wide enough for the swell at the back of the handle, and I've no other option but to forge down that side, make it thinner, just to pull that swell out. In doing this, I thought it's going to make it too thin because the rest of the blade's about 5 to 6 millimeters now. There's me putting that slight curve in the blade, which it has, and working on to bring that swell down on the back of the handle. But as I say, I'm about 6 mil on the blade, really thin, and I thought, well, you know, I can pull this out, and what I can do is put a tapered tang in the knife, so I will grind the handle down to meet that thinner back section, which will look really nice I think on this knife as well. But I'm basically there, guys. You'll see now as I check the length that I'm right up to the end of the anvil, my tip's right, and I've done it. The absolute last step now is to just put it under these flattening dies again, just get it absolutely dead flat, and then we can put it in the forge, heat it up, leave it in there for about 5 minutes, let the grain move around, let it all set, and then we'll put it in vermiculite and get it annealed. There it is, guys. I have actually managed something I thought that wasn't going to be possible. I've pulled it out. I've left it, as I said, oversized, almost forged to shape. I've had to pull this down, make the blade thinner, just to get the back of the knife, the handle out, the swell on the back of the knife. The way it's looking, it's maybe going to be 3.5 rather than 4mm, but I'm more than happy that I've actually managed to get, you know, the knife profile fully out of it. I can't really mess with the front anymore because I think the pattern terminates exactly where I want it. So that's it for now, guys. It's in vermiculite annealing. Tomorrow I'm going to grind that blade, the profile on that blade. I'm going to take all that forging scale off the surface, see what sort of thickness I've got. Hopefully I should have enough. I'm like fingers crossed on this when I've got the decarb off. It's going to have a tapered tang on it, we already know that. If all is good, I'll drill the holes, the lanyard tube. We'll find out what the guy wants for scales on the knife. We'll get it heat treated, sanded, etched, done. Let's see what we've got. Okay guys, come back in the next one. I'll try and get it all finished up in the next video if I can. So see you quite soon, and thank you to all my patrons. Cheers guys, thank you.